Hello, everybody. I hope everyone had a nice, refreshing break. Welcome back. My team and I are very excited to talk about the project we've been working on for the past 5 months called Doko. My name is Tony, and I'm a UX designer with a visual design background. I have Rick here, our creative technologist, and Kosuke, our interaction designers. We have two sponsors, Professor Joshua Smith from the CSE and EE department, and Maggie, an HCI pioneer. Our project is about finding things at home. Before we begin, I would like to share you a very quick story that most of you are probably very familiar with. It's 8 a.m. You had your cup of coffee. You fed your bird. You ate an apple for breakfast. And you went to the gym. What a lovely day. Time to go to work. But wait, oh no, where are your keys? You check the basket where it's supposed to be, not there. You check the kitchen counter, nightstand, bookshelf, work bag, nothing. At one point, you even called your mom for help. Great. Now you're 20 minutes late, your boss is gonna be pissed, you missed your meeting, your lovely day became a terrible day. Losing things is irritating, and yet people are forgetful. In fact, according to a recent online survey of 3,000 respondents, an average person misplaces up to 9 items a day, and an average of 15 minutes each day searching for items like keys, phones, wallets, sunglasses, umbrella, checkbooks, underwears. Yikes! So, to deal with this problem, we revolutionized a system that can help you locate your missing items at home with ease. We call this system Doko, which means where in Japanese. Remote kon wa doko ni arimasu ka? Where is the remote? Doko uses a technology called Ambient backscatter, which was developed by our sponsor, Professor Joshua Smith and his team. The ambient backscatter tags can communicate with each other by reflecting existing ambient wireless signals. These tags use an antenna to pick up signals around us and convert them into microwatts of electricity. So what does this mean and why does this matter? First, using this technology, it means that these tags can power itself by converting wireless signals into electricity. It does not need any batteries ever. No more low battery signals, no more replacing batteries with tiny screwdrivers, never again. Second, and more importantly, these tags can communicate with each other and form a network that can give you a precise location of the item you're looking for. Stop searching, start locating. And now, Kosuke will talk about the steps we took to design this amazing product that will help you find things at home.
Okay, based on the benefits of the technology, we are interested in how the technology can help people find things in the home more efficiently. And now I'm going to walk you through our design process. In the research step, we did a product evaluation and we tried out different kinds of item trackers in the market. This is a brief summary. First, the battery on those products only lasts for 6 to 12 months. It's a hassle to replace a battery every 6 months. Second, they only provide rough signal strength and soft beeping sounds for users as clues to find a misplaced item. After we got familiar with this product space, we conducted 7 field studies to see what kinds of items people want to track in the home. From the study, we found that people know several locations where items are placed in the home. For example, your keys will be at the entrance, or on the couch, or on the kitchen table, probably not in the bathroom. This finding led us to use relative location of object to find an item. In this way, the system tells you where your item is by telling your item is next to your laptop and your mug. You can probably guess where it is in your house. The next step is ideation. We first mapped out the object we collected from the field study into a 2x2 framework. We could identify 3 spaces which items are grouped into. The first group includes items which are hard to replace, such as passport, legal documents, and photo albums. The second group includes variable items such as keys, mobile phone, and wallet. The last group includes items which are easy to replace and people often look for in the home, such as a remote, sunglasses, and charger. The existing products are not well designed for this group, and we decided to target the items in this group as our primary focus. In the prototype step, we created 3 prototypes from low to high fidelity. In evaluation, we employed RITE method, which stands for Rapid Iterative Testing and Evaluation, to quickly find out usability problems. We refined each prototype after each usability testing session. We first sketched out UI screens and refined them into wireframes. Then finally, we refined the wireframes to the screens with visuals. And now I'd like to show you a video to explain how Doko helps you find things in the home.
Okay, so thank you for watching the video. So now let me introduce the Doko system for you. The Doko system consists of 3 parts. First, the Doko tech, which are based on the technology of ambient backscatter, can be powered by the ambient radio signal and communicate with each other by reflecting the existing signal. Second, the Doko adapter. Doko adapter have 2 purposes in our system. One is to provide sufficient signal for the tag to work. Another is to receive data from this tag and send this data to our backend service. We also provide a smartphone app, and after setting up the hardware component, you can use this app to manage and check your item. And now, you might wonder how the system works and how we can provide a reference item for you. So let's talk about some more detail of the system. First, by calculating the signal strength between 2 tags, we can know the distance between them, and with this data, we will know the object, which object are close to the item you are looking for, and therefore we can provide a reference item for you. And furthermore, by doing the triangulation with at least 3 tags, we can form the network map to know the relative location of these items. And finally, by utilizing the gyroscope and other sensors in your smartphone, we can calibrate the orientation of this network map, and while you are moving, and give you the right direction to the item. So basically, these are the underlying theory of our system. So now let me walk you through how to use our interface to check an item. In the home screen, you can filter the item using the search bar, or just click the icon below to trigger a tracking action. And by clicking the icon, the application will show you the information of the item, including space and a reference object. So now you will know the item is in which room and near somewhere. And if this information is still not enough for you to locate the item, you can click on the compass. The compass will guide you to the item. So basically, this is the overview of our system. And 9 items and 15 minutes per day are already frustrating. Imagine what this would be like if we are talking about per years or per lifetime. Through the course of 5 months in exploration, ideation, prototype, and evaluation, we try to solve this annoying problem in our daily life. With the final design of our project, we are confident that we can not only physically save your time when searching items, but also mentally reduce the anxiety when you lose something. We'd like to take this moment to thank our sponsor, Professor Josh Smith and Maggie. Thank you.